I'm going live.
Okay, good afternoon, everyone. Thank you for joining us again at the Atmosphere Conference. My name is Collin, and I will be moderating the end panel session together with David and Olaf, Schulze and Bjarne and Kim. I will be moderating the session, and originally I was only going to be moderating, but following a discussion with Mark Chassero, I was also asked to give a short presentation. So I will do that first, and then I will introduce the other speakers to you. Let me just share my screen. Voila, there we are. So as I said, I'm really curious about the other presentations. I've seen them and I think it's going to be very interesting. So I'm going to keep this relatively brief. I have spoken about natural refrigerants and the solutions that Colruyt Group is using in previous conferences. And for this afternoon, I would say, let us assume that natural refrigerants are a given, that we're not doing anything else. So if we do that, what else can we do to improve sustainability? We can look at using the waste heat of the cooling system in order to heat the shops as well. But I would consider that this is a standard technology as well. So this time I'm going to look into specifically into the circular economy. This is the modular cooling machine that I and my team, we introduced this in 2015. We have been expanding it ever since. I counted more than 130 shops today. And it's a ventilated enclosure, so it's a ventilated system. And so it can theoretically hold up to 4.9 kilograms of propane. In practice, it would be 2.5 to maybe 4 kilograms. On the right-hand side, you see plugs, because the original assignment that I got in 2014 was to make a cooling system that is going to be reusable. It had to be a reusable cooling system. So this was way ahead of the circular thought. And for this reason, I have asked the supplier of this cooling machine, can you make it such that I can send it back in case of a problem? And then we came up with the plugs that you see right here on the top, so that we can exchange the cooling machine relatively easily. So I've spoken about this at previous conferences, so I'll leave it at that. Well, the next step that we did in 2018 is that we also looked at our pumps and our measurement equipment, our connections, and we said we need to make that modular too. So we have what we call skits, setups that specifically provide all the pumps and valves that we need for the cooling part, for the cold production part. So that's also what we do today. Then in 2019, my colleagues took it even further and they put everything in a container. We call it the technical unit within Colruyt Group. And so this is the same technology, but then it's implemented in a container so that it can be tested before it goes into a supermarket. And the driver behind this was the OK supermarket, who wanted to, they wanted to renew their supermarkets quickly, existing supermarkets. Then we said from the technical department, of course, you don't have to install propane cooling as well. And we had to find a way to do this in a quick way, not to close the shop too long. So actually, this is more or less what the assignment was in 2014, to make it, because we can take this technical unit and transport it somewhere else. For instance, we have used it in one location for a temporary store, and then we've moved the same container to another location. In order to do so, we have a test facility. This is an old industrial site, and you see here on the left-hand side 3 technical units ready to be transported to a supermarket. And on the right-hand side, you see 2 photos. On the top, you see a big cooler. That cooler represents the entire refrigeration need of a supermarket. You see just on the right-hand side of that a small part of the refrigerated cabinet, so that we can test the de-icing as well. And in the same room, we will have a dry cooler, a heat. So we release the heat from the cooling machines back into that room, so that we can create an environment where we waste a lot of energy for the test, of course, but where we can test the entire functionality of the technical unit. Then my colleagues took this even further and said, okay, let's also test the skids with the pumps and everything, because the pumps, the skids and the valves were actually mounted on a skid, but then they had to be wired on site. Then, of course, mistakes can occur. So it's the same test facility that was extended in order to also test the modulars, what we call modular skids, or pre-wired and tested modular skids. So this is a very recent development, and the photo on the right-hand side, it was taken in August or even in September this year. So this is really like a first. And I wrote down our preference in case of a renovation, and this is a bit premature because I haven't discussed this with my management. But my understanding is that today we would use a technical unit or a container, if that's possible. If we cannot do that for reasons of permits mostly, I think we would go for pre-wired and tested modular skids. And I expect very soon that we will not be installing cooling machines in a classical way, wiring everything by hand inside the shop. I don't think that we will do that in the future. For new installations, it's a whole different situation. We need to balance the costs of the work we do to make these tested modular skids. You can see, by the way, I don't know if you noticed, but there's a wheel here. So actually, on the left-hand side, it gets rolled into this test facility, and then the whole skid gets rolled out into the supermarket. Just another example of a modular cooling system. It's what you can buy in the market. It's a refrigerated cabinet. And in that refrigerated cabinet, there are two circuits with propane for the cooling. The heat can be released towards the shop, so you can use the heat to heat your shop, or you can release it to a water loop, and then you can bring that heat to the outside, which of course is very relevant in summer. As you can see, we have 2 times 150 grams, or less, I don't know exactly. And the reason for that is, of course, the well-known discussions, can we go to 500 grams or not? And actually, this supplier was well willing to go to 500 grams or one circuit, but having 2 circuits also increases the reliability of a system. So we left it at this. We don't have many of those applications, but we do have them. Just to show that we not only use propane, we also use CO2. Specifically, this is for the OK supermarkets where we have pre-baked frozen bread, and we use there a subcritical CO2 cooling system. Now, something that I was unaware of when I started this adventure was that not only were we making a cooling system that was to be reused physically, my colleagues also started copying the concepts, because I had given them a cooling machine that was modular, and we had given them all the necessary documentation. And then in the left-hand side, you see cooling of the IT equipment in the office where I am today, and the heat is then being recovered and being used to heat that very same building. Or on the right-hand side in Hasselt in Belgium, there was a sudden opportunity to implement, to place a Dreamland shop for toys inside a developing shopping center. And that location, we could not do anything outside. We had to connect to the aquifer system, to the ground force system, and we needed a heat pump. So we then decided to use a prototype propane chiller that we abused, so to speak, as a heat pump. So these are the same components used in a different location. Or we grow inside our distribution center. Inside it, we grow basil and coriander. For the heating and cooling, for the control of the humidity, we use the same type of chillers. And a couple of years ago, Atmosphere, then Checo, visited our first shops with propane chillers, with people from the company Eletrofrio in Brazil, and they made their own version in Brazil, just to see how the concept can be copied as well, not only the physical stuff. Now, after all this positive news, I also would like to share a few of the challenges that we have. And I see 3 major challenges. The first is the failure of components. I think that manufacturers of equipment underestimate the chances that components can fail. From all the different suppliers and from all the different technologies that we use, there are so many components that fail. I don't want to give you a detailed analysis of that, just to mention that we can have compressors, heat exchangers, expansion valves, joints. Everything can break, and it does. And that's actually quite a problem, because we then go to the manufacturer of the heat pump or the chiller and say, well, it's broken, it's your responsibility. But that manufacturer usually cannot do so much because he's dependent on a supplier of the components. Controls is a big issue. We need to control things correctly. That's really a challenge. We have people who know what they are doing. We have our own programmers. We do it all ourselves, but it also means that many people are able to change the settings. That's a challenge as well. And last, sound. The equipment produces sound, and because we install it inside, the sound then can also reach the area where the client is. That's also sometimes a challenge. And although I've been working on this circular cooling for 6-7 years, our organization is not ready for the circular economy. From our procurement, our administration, it is still organized around buy, use, and throw. I'm not blaming anyone. This is just what it is. It's just really how most of our society is built. So this is really a challenge, because when I have a chiller that needs repair, it goes to the manufacturer and then it comes back repaired. How do I deal with that? Is that then a new chiller, or is that a repaired chiller? And how do I value that? How do I keep track? Now, with all these challenges, just one last slide to show you that we can also turn the challenge into an opportunity. Because I was challenged to look into the sound that was produced by the technical units, because some of them were placed quite close to neighbors and there was a little bit too much noise. And I found out in a website that ceiling panels can be seen as a cheap solution, as a budget-friendly solution. And at Colruyt Group, we really like budget-friendly solutions. So I called my colleague who does the procurement for these ceiling panels, and he asked me, well, we are redoing a dream baby shop in Waterloo, which is not so far from our head office. Are you interested, Collin, in having 900 square meters of these ceiling panels? And now I have them. They are stored centrally, and now I'm testing them. This is a photo just taken last week. We are now placing them inside our technical units to see, we're going to see if this actually works as a way to reduce the sound that goes to the outside of the container. And that example fits very nicely within the Iceberg project, where Colruyt Group takes an important part, which is a European project that looks into the reuse of existing building materials. So that's the end of my presentation. And I'm going to say thank you for listening and see if I can introduce the next speaker. Let's see. Stop share. Yeah. David, you're ready, I see. I can't hear you yet, but that will be solved in a moment, I'm sure.
Okay.
Okay. Well,
just putting up the presentation. Voilà.
Very good. May I still say a few words before you start, David, or will you start straight away?
It's like you wish.
Okay.
Be my guest.
So David Schalenbourg is the Director, Architecture, Construction and Maintenance at Delhaize Group. And he has been in the group since 2015. And he is in charge of realizing Delhaize's ambitions to reduce its CO2 footprint by building towards a sustainable brick network. He has graduated as an architect in Brussels and a master in urban planning obtained in Paris, and has an international track record in sustainable projects. We have seen him on different conferences, and he's always a valued guest. And I'm really curious to hear how you dealt with the challenges that you've had.
Okay. Thanks, Collin, for the introduction. It's always a pleasure to be with you and to take part in the ATMO conferences. Today, the presentation, or the subject of the presentation, is something that I feel very concerned about. And when starting and assembling this presentation, it was a little bit inspired by the recent events in Belgium. And when I look at it, we see that for the last years, there have been some events. We had the heat waves in 19 and 20, and everybody also recalls the images of the floodings in the southern part of Belgium. And we can't deny it any longer. So this climate change is becoming a reality. And although I'm an optimist, I would say that this is really a call for action. So we can't hide for this. It's coming to our doorsteps. And even in Western Europe, we felt quite protected. And sometimes you see the images of what happens in the Philippines with tsunamis, or in India. No, it's at our doorstep. So we have to take up and pick up our responsibility. What I want to show you today, how it's impacted the organization I work for. So with the heat waves, the first time that it happened, our installations were put rudely to this heat test. We had 40 stores that were impacted and closed. And we took lessons from that. And we were also, when we looked at it and we did an evaluation afterwards, we said it could have been worse. I will explain why in the next slide. With the floods, it's another part. When you asked me this summer, I was talking with my teams, and for the last 2 years, we've been heavily investing in CO2 installations to go more rapidly forward. But this summer, I was asking myself, shouldn't we have been investing in sandbags? So if you look at the timeline where we come from as an organization, it's already been a while that we're into natural refrigerants. So since 2005, we had our first installation. And 2008, we had our sustainability program. And you see that it's also in line with what happens internationally and on a legislative basis. So today, I'm very proud to say that CO2 is for us the default solution, that no questions asked. We go straight forward, and we use it in our stores, in our warehouses, and we are convinced that it's the right solution to go forward and to lower our carbon footprint. An example that I want to give, so we work with full CO2 transcritical installations. And as I mentioned, we speed up our program for the last 2 years. Why we did it is this design temperature of these old installations is 32, 34 degrees. Now we use a design temperature around 40, 42. And this helps us to be resilient against the climate change. We become more durable. We have less carbon emissions. We are more energy efficient, because we also saw that with the stores that, for example, where we replaced the installation last year, that we gain in energy efficiency about 15% in the same building. So it's quite important. So you see the impact there also in decreasing the energy consumption and certainly our electricity bill. Electricity, on the other hand, is also a very important impact on carbon footprint, and as Collin said before, dirty electricity. So we until 2 years ago, we weren't into green energy, so we went also to the green energy. But I'm a strong believer in structural solutions, like more efficient technical solutions. And then you add renewable energy where possible. And I have to say, Collin and with Colruyt has an impressive track record on that one. We're building more on the classic solutions, solar panels on our buildings, to be less dependent of electricity networks and the rising electricity prices. So another important thing that I want to mention here is in 2016, we became part of a larger group, Delhaize, and since 2019, we also work with science-based targets. Science-based target is, instead of target setting that's based upon some phrase that the CEO says, like by 2030, we want to lower our carbon footprint by 30%, by 2040, 40%. It's compare your results with objective benchmarking. So you really set a benchmark and you're going to compare, and it's a part of also communicating with your stakeholders and showing that you're investing in the durability of the company. So science-based target has become a part of the DNA of the Delhaize group. Within the group, Delhaize is a front runner, so we always look to go further. And so since this year, we also became CO2 neutral. It's a combination of all the actions that we took, and then is there one part, and that I will show later, that's been offset. So this goes together with legislation that's evolving also rapidly. In a Belgian context, we see also that government is more eagerly controlling emissions and is also pushing us forward to replace more rapidly old cooling installations. So where are we today? Today in our network, 2 out of 3 integrated stores are using natural refrigerants. We have a reduction of 44% of CO2 emissions. And that's one. The next one is one I'm proud of. It's 20% of our stores are already free of fossil fuels. It means no natural gas. So we reclaim the heat and we use it to heat our supermarkets, to provide hot sanitary water. We even heat glass houses with it, as I showed in one of our previous ATMO summits. We go also to renewable energy, so solar panels, electrical charging points become quite an important challenge also in the upcoming years, and this in combination with the monitoring of results. So we think that also controlling these installations is very important to show and to be sure of their efficiency. So we're rolling out a new system to create this monitoring, and we're also looking into artificial intelligence to cope with the massive data that will be coming back to us, and to upgrade and fine-tune our technical installations. This is something that we're working very close with our refrigerant companies, and it's quite a challenge. So it's really pushing up the bar and see that we become also more performant on, for example, leak management, installation efficiency, and so on. So this is the technical part. On the other side, we're a retailer, a food retailer, and we know that in the top 5 of impacts in CO2 emissions are 2 other points that we can tackle as a food retailer. It's packaging and food waste. So these are also 2 fields that we're working quite hard on. So it's an end-to-end approach where we also ask to the companies providing us their products to take this into account. It's also a part of science-based targeting. You look at your own scope, your own emissions, but you're also going to look at the emissions that are created before the product arrives at your site, and you also look at it after. So it's more an holistic approach, and I think this is necessary in a time when we're confronted with big events, and we need to align over our domain of expertise to create a maximum impact of all our efforts. I just wanted to show this, the pathway that Europe has committed to. So it's a very ambitious one, but I'm very happy that it's there. So we need to realize this, and everybody needs to bring his effort to make this a reality. If we look at store level at Delhaize, then you see what how the emissions are divided between transport, our logistics, and the stores. Within a store, you see also emissions provide largely from electricity, 30% from refrigerant, and then 20% from heating. So this end-to-end approach is really, we look at the as a whole. So it ends in the store, but it's also your logistics. It's looking for LNG for trucks. It's looking for CO2 cryotech technology for cooled trailers. In the warehouses, we invest also in CO2 installations. We work with dry coolers on our roofs. E-commerce will be thriving and is already thriving due to the COVID crisis. So we see that there's an important increase, and certainly the last mile within the cities is something that's demanding our attention, how we will cope with this. Also, we moved our head offices, and we made, I'm very proud also to say that we kept and we stayed, we followed the line that we created for the stores and our warehouses. So we have a head office now that's neutral and that's heated with heat pumps. So there also, in my scope, which is the managing the buildings of Delhaize, we have now one view on all our buildings, and we really want to go forward in that direction. Here, just to give you an idea where we are today, so 2021, we already managed to cut our emissions in two. You see also that a large part of the emissions is caused or is in our affiliated stores. Affiliated stores are our business partners, and we are now tackling and training them and informing them about all the efficiencies that we found in our integrated stores. Integrated stores are company operated stores, so they're operated by Delhaize and by Delhaize personnel. Affiliated stores are B2B, and where we deliver goods as a wholesaler. So there we have an important part to tackle. Logistics, and then the commuting is also an important part of emissions. What will we be looking at in the upcoming period till 2025? So the renewable energy is an important challenge in all our supermarkets. Low GWP refrigerants in all supermarkets, and it's, as I told you before, we go for CO2. For our smaller stores, we also go for propane and plug-in cabinets. So there we see how the market evolves. E-commerce is an important one, LNG, and then company cars is also one part of the challenge. So just to give you an idea what we're talking about, so Delhaize Belgium, Luxembourg has about 800 stores, 5.2 million customers a week, and it's divided, or you have different brands within the Delhaize brand, and you can see here on the right side of your screen a little bit of division. The 128 stores are our flagships, and then they are listed in decreasing size. And to end this story with, we're part of a bigger group, and we're also with Ahold Delhaize in the Dow Jones Sustainability Index, and we are very proud of that, and we want to continue building on that. So for us, it's really, it's about selling products, but you want to sell quality. For us also, the health of our customers is very important. We try to help them make good choices to eat healthy, And to eat healthy, you also want to sell this healthy product in a healthy environment, which doesn't impact our planet and which helps to go forward. So this is one of the ambitions that we will be keep building on, and I hope to tell you more on the next occasion what the next steps were that we realized. Thank you very much.
Thank you very much, David, for your presentation. I have one question that I saw passing by in the chat. The question is, do you have natural refrigerants in the truck cooling systems? Do you have solutions? Did you find them?
Yes, we have. So we use Cryotech.
Okay.
And Cryotech is it's with CO2. So we have in our warehouse site in Zellik, we have a station where the trucks can charge CO2. Mm-hmm. And one of the advantages is it's a silent system. So it also helps us when we have to deliver in an urban environment to not wake up our neighbors. The only thing is it's not available at large scale in Belgium today. I think there are 2 filling stations, and with one load you can drive around 400 kilometers, I think.
Okay, thank you very much. Given the time, I would like to go to the next speaker. We will come back to you with further questions afterwards. The next speaker, Olaf. Let me introduce Olaf. We have seen him on different atmosphere conferences, always presenting really interesting stuff. He always famously mentions that he is a lawyer and not an engineer. And in fact, he is Director Energy Management and Real Estate Sustainability at Metro Properties Holding. And from 2005 to 2013, he was the Managing Director of Metro Properties Energy Management. Olaf, the floor is yours. It takes a moment before all the technical issues are solved. Let's see what we're coming.
You have now a technical issue, Collin.
Yeah. I hear
listen you. Yeah,
I can hear you.
Yeah, wonderful. Perhaps somebody can upload. This is a typical issue in such a wonderful presentation that I cannot upload now my presentation. Perhaps the Rishi can help me. But as first, thank you to be also with you in this conference today. I can make it very briefly and vocal. And by the way, David, in one hand, it's really amazing what you are doing with your company, and the second, it's shocking what you presented as first picture for the flood issue, in our stores, and therefore in Belgium in the summer, and therefore we as manager, we as community, we are responsible also to manage our technology and to safeguard. Wonderful, thank you very much. To safeguard our climate. And by the way, our store in Liège with a really new transcritical cooling equipment was 2 centimeters before we had the impact from the flood in the store. Therefore, we were happy, guys. We had in this year, last year, installed a new cooling equipment, and it was safeguarded by coincidence. And the transcritical system CO2 technology for us is definitely a solution to safeguard us for the climate risk. Perhaps we can go on the next page. Thank you to the regie that you were able to support me. Also similar like Delhaize, we are in the same code of conduct. We have the same obligation, and we are committed until 2040. We as Metro, we like to be climate neutral. How we like to proceed this way to climate neutrality means zero emission in own operation.
Oh, I lost you. Olaf, I didn't. Oh. Yeah.
Collin makes it down up. Now it goes. I'm not sure what has happened. I'm in my office. But now I can see. Makes it down up when you can see me, dear Collin. Then I can see
Here again.
Wonderful. And sorry for this interruption. I'm not sure what is technology. They are the climate risk now today on our computer, that we have interruption, for example, in supply chain, in cooling chain. But therefore, give me this apologize that I can go forward. Energy saving program, crystal clear, invest in clever technology, F-gas exit. This I'd like to explain later in the next page. We like to step out of the usage of hydro and fluorocarbons, of course. Photovoltaic, we listening it. This is amazing progress from Delhaize. Also, Metro has a similar program. Then the rollout of green zero emission stores means each new store opening, either in Russia or in Germany or in Portugal, should be in the future climate neutral. And we created new measures. One is the heat exit program. Collin, it was a part of your presentation. Step out of the usage of fossil heat, how we can do it. Of course, with heat pump, with heat recovery in the main, but also clever issues like solar heating and decarbonization of our of our car fleet. And the green logistic is in brackets because for green logistics, we have until now not the own target, because we have CHP, we have LNG, but the real electrical or hydrogen trucks are not available. It is a part of the future, but the part of the honesty, and perhaps you can move to the next page, dear all, is in the last end, we have to compensate and capture some remaining CO2, but it's not possible to reduce it by physics, means by natural refrigerants or by energy efficiency. Dear all, we have a created F-gas exit program. It was created in 13 in the end. We like to install in each new store opening, wherever in this world, and in all refurbishment of existing stores, only natural refrigerants. We like to do it in accordance with the life cycle. Clear, when a store, HFC store is end of life cycle, we like to install only natural refrigerants. You know it. NatRef means GWP lower than 150, but in the practice we are using CO2 or propane. We are focused in the main. We are focused to transcritical cooling technology with ejectors and with heat recovery. Of course, we have some stores like a new store in Kazan, in Siberia, near the Ural, in the middle of Russia, where such a ejector makes no sense. We don't need it in this climate zones, but usually we are installing it. And then we should be also aware, for example, here examples in Belgium, Netherlands, and Ukraine. We say smart repair solutions. They are smaller exchanges, usually the deep cooling aisles. They are old, they have temperature problems. We have a lot of maintenance and repair, and we have high leakages. Therefore, we are decided also to accelerate our F-gas exit program. That in such cases, and in the 3 countries we did it, for example, in Machelen, in Dordrecht, in Vianen, in the Dutch and Belgian store, that we took some equipment out and we put plug-in in to accelerate our leakage management. In the end, we are supporting member of the Consumer Goods Forum, and therefore we have double obligation, or we have 3 times obligation for our customers, for our environment and also for the associations where we are committed. And the benchmark, and it is not new, the benchmark is a leakage, right? The problem is not the HFC in the equipment. The problem is the HFC in the leakages. And unfortunately, it is a part of the honesty. We have actual last running 12 months leakage rate by 8.5%. Next year, by the way, we will come below 8%, but we have the 8%. And here you can see from the left side for Austria, 2.5 till the right side, 20, so 10 times more in the end, or 8 times more, more than 20% in Ukraine. They are the real leakages that we are measuring in the last 12 months. Perhaps we can go to the next steps. Therefore, summary for this page, F-gas exit. What we are doing? We have now 135 transcritical system in a couple of countries. In Austria, Bulgaria, in Poland, Romania, Russia, also in Slovakia, and in Germany, of course, not as main country, as mother country, of course, too. Our first TC equipment we installed 2008 in Hamburg-Altona. We have additional 76 subcritical stores, or we have also installation like ammonia in our storages, or propane as smart solutions. And we have a couple of stores in retrofit. It means here we took out the R404A and put in, for example, 448A and GWP lower than 2500. We are not proud about it, but it is an interim step to reduce the climate impact from the leakages. We are not reducing the leakages really, but we are reducing the climate impact. And Collin, here I like to look and regard to your presentation, a connection with this heat exit program. Heat energy we like to reduce by heat pumps and heat recovery. What is the outlook? The outlook to all, the next year, we like to double the amount of stores and the capex, what we like to transfer from existing old HFC to new transcritical equipment. We have some white spots. It means countries where we don't have until now TC equipment. Next year, Portugal, the first, also in 2 stores TC, in Hungary, in 2 stores TC, and in Ukraine, KFT Remki, our first store will be equipped also by such technology. It means we are exporting best practices, technology, experience, maintenance and repair also to other countries. And this white spot we like to delete. Energy efficiency, and I mean also Collins and David, they presented, I can only repeat. We have a lot of opportunities like the closing of cooling shelf doors. In the end, we did it for deep cooling, I forgot, in the last, before 2010. But in low cooling, we are not 100% solved. But in Russia, we have a program we started last year. In few months, it will be completed in each store, for example, in Russia. Low cooling is in this time also for energy efficiency, for temperature stabilization closed. And the all maintenance and repair is a real issue during the life cycle. We like to optimize our total cost of ownership. Here, the name is Iceman Project. We are doing it together with our partner, with Carrier. And Iceman is this project name was coming clear from Ice Machine. But in the end, Top Gun, who was the winner of the Top Gun trophy, in this autumn will come the second movie. It was Iceman and Slider as co-pilot. Therefore, it should be our way in the future to the future. And of course, outlook means we are looking for leasing, for refrigeration as a service solutions. We say for that premium service packages. We have some great ideas together with our partners. Not solved until now in Real, in our salt hypermarket chain. We did it in one case with E.ON, but the future, it is my opinion, it is our aim where we are working to, that we have higher standardization, higher harmonization, and in the end that we are buying refrigeration as a service. What we need in our stores, dear colleagues, is cooling. We don't need capex. Cooling is important, that we can sell in the wonderful way in the closed supply chain and cooling chain our goods. Therefore, the all last page without any technical interruption. Now it goes liquid. Next page, the all. I'm so happy that it needs. No, it's not too much now. This is my name, Olaf. The rollout plan. We have. I mean, it is a little bit the basics. Everybody is working more or less for the same plane. What we are doing, we are scanning all of our stores, from India till the Netherlands, from Kazakhstan till Portugal. In between are Germany and Austria, Czech Republic, Slovakia. The exchange we are doing when equipment comes near of the life cycle. Therefore, we have a plan store by store until 2030. And by the way, until 2040, definitely the first transcritical equipment, for example, as I mentioned, 2008, Hamburg-Altona, will be renewed. We are coming in the next years in the first step that we have new transcritical equipment to adjust by new transcritical equipment, a newest generation with booster, with ejector, with heat recovery. Clear, we are focused to the countries with short-term obligation, the European Union, but also Turkey. It will come in 23. Serbia will come. Moldova will come in 23. You will see also other countries, they are not in our focus now from the European Union perspective, but where we are operating will get such technology. And the low GWP in India, Kazakhstan, Pakistan means in these countries, in Pakistan, we opened in Multan a new store opening. We have not CO2 technology because the maintenance and repair could not guarantee it. Therefore, we have a low carbon solution, of course, lower than 2500 R448A. It is also part of the future, not of the future, of the honesty. And the focus will definitely be in the future because the equipment, transcritical equipment is solved, hook, energy efficiency, heat recovery, and the manage as general scoring methodology, and then we can stop. And I'm over is AC. The age and condition of old equipment, stores with higher leakage will be faster renovated than stores. Also with HFC, like in Austria, 2.5% leakage rate, it could come a little bit later. But last sentence, next year in Austria, we like to refurbish the stores in Innsbruck and in Salzburg. Dear all, thank you that I could speak today, and sorry for some technical problems, but you can see technology is living a little bit with spirit and a little bit with arm length technology, but we have a clear focus. Therefore, let's fight together for a clean climate and for natural refrigerant in our stores. Thank you very much, and thank you, dear Collin, that I could be here today.
Thank you very much, Olaf, for your presentation. Just one quick question. The 135 stores that you mentioned, are they only for the countries indicated, or is that all metal stores in Europe and beyond?
No, they are the stores. They have transcritical technology implemented. Over the whole world, we have more than 600 stores.
Okay, that's my question. So you have a lot more. This is really for Europe.
Yeah, clear. Yeah.
Okay.
They are stores, they have the new equipment and they are proper operating, like I mentioned, Hamburg-Altona or Liège, where we installed in 2021 this new equipment. By the way, only for our friends from Belgium is a majority in this round. Next year we will have new equipment in Icke, in Wouwelgem, and in Machelen we will have the deep cooling ice adjusted by a plug-in solution from AHT, our friends. Thank you, Collin, for your question.
Thank you very much, Olaf, for this presentation. Given the time that we have left, I suggest that we go to the next speakers, and then we'll have a round of questions afterwards further. And so please allow me to introduce the next speaker. We actually have two speakers, and I saw they're going to talk about hybrid ammonia heat pumps, and I'm really curious how that works. So the first speaker will be Bjarne Horntvedt. He works for Hybrid Energy, and he has worked in industrial energy saving and energy efficiency for 32 years, and for 16 years at the Institute for Energy Technology, IFE, as a research scientist, and the last 16 years as the founder of Hybrid Energy. So he's the manufacturer of the industrial high temperature heat pump that we're going to learn more about. And he brought with him André Lovas from Tine. He has a master in mechanics and process technology, and he's presently working in several research projects related to heat pump technology. I understand he also represents the end user. So Bjarne and Kim, please, the floor is yours. Go ahead.
Thank you very much for that introduction, Collin. And I'll try to share the screen here. Let's see where it goes. Presentation, whiteboard, maybe. No, I have the same problem as that. Maybe that's it. Is that it?
Yeah,
Yes.
it's there.
There you go. There you
You
go.
can just make it larger, that's all.
Yeah. Make it larger by doing
At the
the
bottom.
here. Okay. Okay. Thank you for letting us come to present this. André, I will talk for him as well. It's you know, this is industrial energy recovery, and Tine Bergen is Tine is the largest dairy source in Norway, and they should build a new dairy, and they decided that they should do maximum energy recovery, and that's what I'm going to tell about.
Bjarne, can I just interrupt you? Can you show the whole slide in the shared screen? Is that possible? Because we now see two slides.
How is that now? And I will then need to push.
It's somehow not full screen. It's showing you as two slides.
Yeah, but you know where to pull to press to get it. It's what two is it? Is it the first two? Is it,
it's Collin here. Just notice that we see two slides. That's why.
Yeah, I understand, but I don't know where to push to get the full screen.
Okay, well, they'll work it out. Okay, go ahead. Go ahead.
Sorry, Bjarne?
Yes.
Do you hear me? Okay. So from the buttons that you have there above your screen, vis uppgave linje and the second one, the ones above.
Yeah, this was even worse, wasn't it?
If you go back, yes, from the three buttons that you have above your screen.
Yeah.
The ones that are above.
Above.
Yeah, up on the window. You have three buttons, vis uppgave linje, and there is another one. Well, if not, maybe just keep it like that. Above, like the ones that are there, the second one. Yes, click on the arrow. The second button, click on the arrow and change it to beat melon. That one.
What was better?
Exactly. That's it. Thank you, Bjarne.
Okay, sorry about clumsiness. I'm used to Teams and not Zoom, so that's why. Sorry about that. And yeah, Kim, do you want to add something? Then just fill in. So that's okay. Okay. Tine is a big corporate owned by a Norwegian milk producer. So then I should try to get away because it's not covered by the. And they want to modernize the dairy industry, and so in that way they had the first dairy completed without fossil fuel use. That was the main target, and also consumption should be reduced, and the goal was like the 40% reduction in energy use, and Tine also got support from Enova. That is the Norwegian organizer for supporting energy efficient solutions. And this system was a winner of a few heat pump projects in Europe and also in Norway. So But I would like to show you a detail by the usually energy central for an normal dairy. You have the chillers, of course, that you need to do the cooling, 1.5 degrees for cooling the milk and cooling all the pastures and things like that. And when you do energy recovery, you can take out the heat from the condensers and things like that. And then, of course, you have a boiler, like a fossil fuel boiler. That's the standard system. And then you can heat the pastures and things. And of course, you can also heat building and hot water and everything from that. But when we want to do the maximum energy recovery, you will change it into, you have the chillers for doing the cooling, but then you have intermediate thermal energy stores. So that will be like for this situation, a 40 and 20 degrees tank for certification. And then you can also recover some more heat from compressors and other things. So I see a lot of comments on it. It's not very nice. But anyway, yeah. And you can do snow melting, and you can do use the energy from the dry cooler. Of course, you need a dry cooler if you have excess of heat. And in this system, we have the intermediate heat pumps with natural refrigerant ammonia, and making up to 67 degrees that you can use for building heating and other things. And you also have a backup for district heating to this tank. And for using our high temperature hybrid heat pump on the top for making 95 degrees. It needs to be said that this dairy had enough with 95 degrees, because it's also built in very efficient systems like the pastures and other needs, high temperature needs, and that is very good. That is a basic of this energy efficient installation. And electric boiler will be used as a backup if the heat pumps is break down or have a service, or if the waste heat is not enough. And to have this system, you have thermal storage tanks, like a few in 130 cubic meters of water, and also for the cold side, for ice water for 0.5 degrees. We have the capacity of the hybrid heat pump is 940 kilowatts. And the cooling capacity is 1577. So this was a good system for Tine's, making a good energy savings, and you had a lot of key success factors. To be able to skip the time, I just go very quickly through this and go to, this is the picture of a hybrid heat pump in the corner, the skid, with the low pressure and high pressure tank, and that's it. And of course, it's a compressor in addition to that. And this is the energy flow through the whole dairy is measured by some at Sintef and NTNU in Norway. And the old dairy in Bergen was like 24 kilowatt hours per liter milk, and a newer dairy we expect, when after fine tuning, we get down to 15 kilowatt hours per milk. This is a picture of 1 week in a very early stage. So then you can see that they use the little district heating up to the left. And you see the electricity, which goes to chillers, goes to intermediate heat pumps, and it goes to the high temperature heat pump. And you see the process heat. And the cooling, of course, is the waste heat source. It's like from buildings and process cooling to the lower left. And then you can see also that the building heating at 67 degrees. This is a very good view. We also have it on screen, so you can see it in practical way. And I just wanted to say that You've been using this hybrid heat pump. It's not very common that you can blend water into the ammonia and you can get the pressure down. And you can still use compressor as a normal system. So we use about 50% water and 50% ammonia, and we can go up to 120 degrees with the standard refrigeration equipment, which all dairies know from before. And when you have a good temperature glides on hot and cold side, we get extreme good deltas or COPs. And like I said, standard refrigeration system, but also after you have installed it, you can change it by changing the mixture rate in the water and ammonia. You can change not 50-50, but you can change slightly, and then you can adapt to either colder temperature or even hotter than design 95. You can also with this system give 105 if needed for some reason. So this is just a view of the process. It's just in addition to a normal condenser, compressor, evaporator, and expansion valve, you have a solution pump and you have a gas liquid separation tank. So because of the short time, I will just go very quickly to it. And this is the range for our capacities on this system. And you can see that you can go up to 120 degrees for like up to 5 megawatts of system, but I will need us to use screw compressor. The smaller is piston compressors. That's ready. That's what we used in dairies. Standard piston compressors, like you see on the left side, very frequently used in the industry, especially in the food industry. So this is here is used the Sabro compressor. So then you can see also another two-stage system that we have from you see in a fish feed factory where we're taking out heat from the moist air, about 1 ton of water per hour, and also will reduce the smell in the area. So and the whole factories get 20% less energy use with this. So, do you have anything to add, Kim, André, or else I will just say thank you for listening.
Thank you for the presentation, Bjarne, and I think that gives a good overview for the case we had on Bergen. And I would just add that we had a big goal for this new plant of ours. We wanted to reduce the energy by 40%. And after 2 years running now, we can say that we not only met that goal, but we went beyond the goal, and we ended up reducing the energy by 53%. So we are very excited by seeing how this solution can reduce our energy in different plants also. Thank you.
Thank you.
Thank you very much, Bjarne and Kim. Thank you very much for your presentation. That was very interesting. I will start with one question, and I hope I see some questions in the chat from the audience. So my first question would be, what can the hybrid heat pump do that the ammonia heat pump cannot? How do they really make a difference for the user?
The maximum because of the pressure that gets high in the ammonia, it's usually limited to up to 90 degrees, and we can do with the low pressure the compressor, we can do 120 degrees. So by adding water, we can add, it's a real high temperature heat pump with much lower pressure, especially for big industrial heat exchangers. So it's more safe to have 18 bars than 63 bars in the
Yep.
like.
Okay, excellent. Thank you very much. Maybe the other speakers in the end user panel have questions for each other, or please go ahead. I don't see many questions in the chat yet. I have a few questions for different speakers. Maybe one for David. Do you have small stores that only use propane cabinets? And if so, are they water cooled? Do you have that?
Yes, we have. We don't use them as a default solution. And as you saw also in the smaller stores are operated by affiliates. So we have just a few smaller stores which are company operated. The ones we have, we take the advantage a little bit like you do at Colruyt to do some testing and see what's feasible. And then we try to convince and show them, because with smaller stores, you know that the heat, if you don't reclaim it, it stays within the store, and you just leave the doors open to get the place ventilated. So yeah, it's a good solution, but it's not commonly used. We have, for example, in our new head office, we built a small store with also plug-in cabinets, and there it's a propane solution.
Olaf, do you want to add to that, please?
Yeah, also we had some problems in stores, for example, in Brunnthal, a big mini store, the classic 20,000 square meters, or Hameln here in the middle of Germany. And we decided to install plug-in solutions for the deep cooling, also like what I explained in Machelen or in Dordrecht, but in some stores also in Germany, also usually we would install transcritical technology, but to accelerate, to save time, and to have fast solution also for the customers, by the way. Therefore, we are doing it, and I think plug-in solutions, they have also a big flexibility. So we are saying, for example, in Brunnthal, this year, we have these plug-in solutions, and in case when in the next years the full completion, this new transcritical equipment will come, then these plug-in solutions are moving to another store to solve the problems. Therefore, we are flexible. Also it is a proper technology, is quick and dirty. It's not dirty. Quick means a fast solution, and we are very flexible. We can move it from store to store, and therefore, in my observation, we are more and more often using it because it is a flexible smart problem solver.
Yeah, it's like a kind of plug and play solution, huh?
Yeah, definitely.
Yeah.
A quick and dirty, I said, but plug and play is better. It's
plug and play is better. No. We also use it sometimes when we do projects that need a store closure, and then we build a temporary store, or we put a kind of tent next to the store, and then it's also a solution that can be provided. So yeah.
Yeah, I can confirm from our side as well. We also use it in some occasions, and the flexibility is a very important point because you can implement it really quickly. Okay, David, you mentioned your affiliates. How strong is your influence on affiliates? They make their own choices, of course. How do you deal with that?
Then you need to put yourself in the shoes of an affiliate. What does he want to do? He wants to earn his living. So for him, it's the wallet that's talking. And if you can prove that it is a sound business choice to go to natural refrigerants, and when you see with now the price of with the phasing out, the prices are raising. So you see there, it's an ending story. And they also want to be left alone by the government, and that they have a solution, an installation that's working fine, that's energy efficient, and that has a lower energy bill. So we also find by time, if you asked me this question 5 years ago, I would say, okay, we still have a way to go. But meanwhile, I think also in Belgium, even refrigeration companies are just now advising by default to go to natural refrigerants. So it's become more easy, and we're not the only one who's saying this. So you see that the conviction that this is the right choice is only increasing, and everybody is going in the same direction. But we need to speed up.
Didn't I actually read correctly that you have an affiliate installing an ammonia heat pump, ammonia refrigeration system in Belgium? So actually, they can also be very advanced.
Yeah.
Also happen.
Of course, because an affiliate it's as you say, he invests his own money. So the only thing that we can give is our advice, our support, and we have one of our affiliates who's also very driven by durable sustainability. So yeah, he installed an ammonia installation.
Okay.
And I also saw before, like in the States, you also find these kinds of installations in stores where you have a unit outside, a little bit like the system you are using also in Colruyt to keep the negative aspects of ammonia outside of the building.
Okay, let's stay with ammonia for a moment. I see from the chat that people are really asking to Bjarne and Kim. So is that really a mixture of ammonia and water? Because I see that people are quite surprised. Can you please explain how did you ever come up with this solution?
Well, the mixture of water and ammonia has been to absorption machines for 100 years ago, maybe the first. So this is a good way because it's we call it hybrid heat pump because it's a hybrid. It's both the absorption process and it's a condensation evaporation like a compressor side. So it's in fact it's an old patent from 1895. The Osenbrück site. It is. So we just made it work, and we made it with the compact heat exchangers. So it's possible to build it on a smaller, very small, not small, but I mean smaller. And it's a practical use, and it's no problem with the corrosion or no problem with anything. It's just working. So the compressor makes the process react very quick. So it's more like a natural what do I call normal heat pump. So it works just like that. But we have also, when we have a combination of water and ammonia, then you understand that the boiling point and the evaporation point is changed through the heat exchanger. So this is a perfect match to large delta T's on cold and hot side. So like in the district heating, you want to take as much heat as possible out of water when you send it to the customer, and that perfectly matches what we also want to have for having the good COP. So the idea was to get a hybrid heat pump with standard equipment. That was the basics. High temperature heat pump with standard equipment, and that was the idea that a water and ammonia mixture is a good solution.
Wow. And in fact, a temperature glide is something that we know very well in CO2. In transcritical CO2, we have a large temperature glide as well, and we can actually use that to our advantage. Colruyt Group uses small CO2 heat pumps to make tap water for the butchery. The butcher, basically, because we cannot do that with our propane chillers.
We have it on both sides. So we,
exactly.
When we cool moist air, we need to cool it rather much down because you need to condensate out moist. So it's a perfect mix match for like a situation like that. And also you put the process in series, like and from the CO2 system, we can also do that as well. But we can also change we have a pump and a compressor. When we change the capacity, the compressor and the pump, we can adapt to the glide. So in summer and winter condition, we can change by just changing the capacity through this. So it's a very flexible system even after install. So
I can imagine Colruyt Group uses a large ammonia heat pump for its meat processing factory in Belgium. And as a side note, we then wanted to mention to the government that we are using the waste heat of ammonia, this ammonia heat pump for heating the building, to take that into account to the official energy certificate of the building. But ammonia is missing in the Belgian rules, so we can't put it in. I'm sorry. Yeah. But nevertheless, we did it anyway, and it works efficiently. But it is, I know from the engineers who did this, that it is a challenge to match the different temperature glides, because you have the heating system of the building on the one hand, you need to heat cleaning water on the other hand, different temperature profiles that you need to match. So very interesting.
Yeah, but that's be sorted by the distribution system. To do a smart distribution system, you will match with that. Very good.
Very good, very good. Well, I don't see any more questions popping up in the chat. Let's see. Let me just chat for a moment. No, not really. So unless one of the other speakers has a question, or then we can actually go to the closing of this session. I would say thank you very much for the very interesting presentations. All of you, Bjarne, Tim, David, Olaf, it was very great to meet you here on the end user panel. I know and understand from Mark Chassero every time that the end user panel is important because these are the companies that actually purchase the equipment that is then being used. And it was very interesting to get all your perspectives here in the panel. Thank you very much for being here. Thank you.
Thank you.
Okay. It was a pleasure. Bye bye. All the best.
Okay.
Bye.
Tschüss.